Lesson 5.6, Proving Triangle Congruence by Angle, Side Angle, and Angle, Angle, Side. Essential question, can I use angle, side angle, and angle, angle, side to prove triangles are congruent? Here's the theorem. If two angles and the included side of one triangle are congruent to two angles and the included side of another, then the two triangles are congruent. What you need to notice about this is this right here, that the side we're talking about is included between the two angles. Here's the proof. The proof is a rigid motion proof. What we're going to do is we're going to take one triangle and we're going to translate it so that D matches to A matches to D, and that's going to happen right here. Now what we're going to do is rotate it so that C prime will rotate to F, and this is the rotation, and you can see we get this. Now this is a very interesting situation. This angle and this angle are going to be congruent. So this looks like a reflection. This side is reflexive, and then this angle will be congruent. So we can go through a reflection because we know these angles will match, these angles will match, and of course the third angles have to match as well. And so this, in essence, we're going through three transformations to show the mapping. The next method is called angle, angle, side congruence theorem. The side is at the end, notice, and that's because it's a non-included side. Non-included side. And here's the proof. We get these two angles congruent to these two angles. So by the third angles theorem, we know we're going to have this angle congruent to this angle. And once that happens, we have angle, side angle. And so we can say these triangles are congruent by angle, side angle. It's already been proved angle, side angle is a rigid motion transformation. So we know angle, angle, side will yield the same results. All right, let's take a look at how to do a proof. This is an angle, side angle congruence theorem application. But let's see if we can go through it and see the angle, side, and angle. Now here's some parallel lines. And of course, parallel lines will give us some angles. So I'm going to go ahead and show that. And you can see that this angle will be congruent to this angle. Remember, these are parallel lines. These are alternate interior angles. So I can see an angle pair. And I can see another angle pair with these vertical angles. I see another angle pair. And we have some sides that have been given to us. So we can say that they're congruent. Now notice the S is in the middle because it's included, and there's my plan. Okay, you should always come up with a plan before you start doing the proof. All right, so in the given, we have the two lines are parallel, so we get angle D congruent to angle C if two lines are parallel. That's coming from the previous line right here. Then, and these are alternate interior angles are congruent. BD is congruent to BC, that's from the given. And now we're talking about our vertical angles. Vertical angles are congruent. Now we have our angle, our side, and our angle, so we can say the triangles are congruent by angle, side, angle. And again, angle, side, angle is a shortcut for rigid motion. Let's take a look at another where we're not being told what the answer is and see if we can come up with it. Now, we know that we have some right angles. So already we know that when we have right angles, we are going to have, we can have right angles that are congruent. So this is going to help us. This is going to help us with an angle pair. Now we have these parallel lines. And again, parallel lines will give us angles. We'll give these two angles, alternate interior angles. And then we have a reflexive side. So we have two pairs of angles, and we have a side. Notice that I didn't put the S between the two A's because this is a non-included side. So that's my plan. All right, let's go ahead and go through the proof. We have these angles. If two lines are parallel, then alternate interior angles are congruent. we have the right angles, but the next step is to say that they're congruent. Right angles are congruent, that's a theorem. And then we have this reflexive situation, reflexive, and now we have fulfilled the angle, and the side. So we can say the triangles are congruent by angle, angle, side. And again, angle, angle, side has been shown to be a product of rigid motion. Okay, can I prove the triangles congruent with the information given? And so I'm going to change my color here because a lot of stuff is in red. And the first thing I'm going to do is I'm going to work with these parallel lines right here and this transversal. So I can see that angle 2 can be proved congruent to angle 4. If two lines are parallel, alternate interior angles are congruent. Okay, let me pick another color. I'll pick purple. And here's parallel lines, and I'm going to use the same transversal. And you can see with the purple lines, this angle is congruent to this angle. Now we have two pairs of angles of one congruent to two pairs of angles of another, and we can see we have a reflexive side between them. So it's either angle, angle, side, because we have two pairs of angles, or angle, side, angle. And so you need to decide, is it an included side or a non-included side? And you can see purple angle, and then you can see side, and then green angle. So it's going to be this. Now, let's take another step and decide how to put the letter order, the congruence. So I'm going to say triangle, and I'm going to do that top triangle, X, Y, W, congruent. Now, it doesn't matter how you start, it's how you finish. So angle Y of the top triangle has to go with angle W of the bottom triangle. So I'm going to put the W in the middle. And over here, angle W of the top triangle, here, angle W of the top triangle has to go with angle Y of the other triangle. So I'm going to put a Y here. And there's only one letter left to work with, and that's C. And that's how you go ahead and set up the correspondence there. Okay, here's a proof. I'd like you to stop the screencast and see how to do it, see if you can try to do it, and then turn it back on to see the results. Now here are the results. My plan was angle, side, angle. Now the perpendicular lines right here are going to be helpful because perpendicular lines help get right angles, and that's what I did right here. I noticed that I have some right angles. Now remember, you can't use these letters A, S, A unless you have congruence, so that's why I had to go to the next step and say that they were congruent, and that gave me an angle pair. Vertical angles we've been using quite a bit, and then the given. Here's another opportunity for you to try a proof. Stop the screencast, see what you can do, and then take a look. And here's the answer. My plan is angle, angle, side. I had an angle pair in the given. I had a side pair in the given. So all I had to look for was another, which was vertical angles. And once I get vertical angles are congruent here, my choice is either angle, angle, side or angle, side, angle. And I definitely don't want this one because this side is not between the two angles. And that's why my plan was angle, angle, side. Here's the summary. There are 5 ways to prove triangles are congruent. Only one of them is for right triangles only, right here. And you notice we are using the letters H and L instead of S for sides. So we have side, angle, side, which is our first one, and side, 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 and HL we learned in another lesson, and we just finished these two. And there aren't any more methods to prove triangles are congruent.